Welcome to qnawire.
In this problem, we have a wedge sliding on an incline, and then another block on top of it. And so it's kind of said that be careful about the kinematics with this problem. So we can draw free body diagrams. We take this top block here, and we get a normal force. Fortunately, they tell us that there's no friction here, so that simplifies things a little bit. So we have the normal force and the weight. And then for the wedge, we have the normal force from the block, which I drew in the wrong direction. Drew wrong. It has to be equal and opposite to the one I drew in the over here. So then we have the weight and then the normal force between the incline and this wedge. And then we know that this thing is going to has motion in this direction here. And this one, well, relative to this block, if you held this block fixed, its acceleration would be like this. But its absolute acceleration is going to be a combination. So the absolute acceleration is going to be the acceleration of B, or the acceleration of A is going to be the acceleration of B plus the, I write that, well, yeah, you can say it that way, but I think I really should say that you better to write it as acceleration of, let's see here, which one? This is B up here, A, and B with respect to A. There we go. All right. So that makes a little more kind of sense, just to write it that way. It doesn't. We would have just gotten them different signs if I wrote it the other way. And I'm pretty sure I just messed up writing A and B's here when I copied it down. Now, what we're going to do for this block, we're going to take forces in this direction right here. Now, in that direction, we have NB. Then we have minus WB cosine alpha. So this is this angle between here and here is alpha. And that equals the mass times the acceleration of A. Okay. Now, why is that? That is because so we have minus. So we have this guy here. So we know this one. Well, partly is because this acceleration of B with respect to A has no component in this direction. So all we know, we just have, and I think, yeah, I need to make this needs to be a minus sign in there, because I have positive and opposite directions. So if we, in this direction, the acceleration of B, this component is 0, so we just have this. And that is in a direction this way, and with respect to this angle, it has an angle of alpha plus beta. And again, just draw some little triangles right here. So we have here, and then this one is going down this way, and so you can figure out that that's the angle between this axis and this vector here is alpha plus beta. Now, let's see here. This guy over here, we can take some forces, and which way are we going to do this? We're going to do it along this axis here. No, well, along this axis here, this direction. So that means we have WA sine of beta, and B, we wind up with cosine of, there's various ways to write this, but cosine of pi over 2 minus alpha minus beta. And again, you can just kind of, we're along this axis, and so we can figure out, this one is 30 degree beta with respect to this, and this one is, alpha with respect to that, so you can figure out the angle of this vector here with respect to this axis. So it'd be like this axis. And that turns out to be this. The component then winds up being, the cosine of that angle. And so then we have the mass of A times the acceleration of A. And now if we notice, if we look here, we have, let's see here, in these two equations, we have two unknowns, the acceleration of A and then the normal And so we can solve those, or we can basically solve this one for MB, plug it into here, and then solve everything for the acceleration of A. And so I didn't go through all the algebra, but it's pretty standard algebra. Two equations, two unknowns. And so I guess I didn't write down what this was because he didn't ask us, but we get the acceleration of A is 6.41 meters per second squared. So it's sliding down this incline as we expect it to. Now, if we take a look at if we do force balance in this direction here, right, then we have WB sine of alpha, and then the acceleration, there's no component of this in that direction. And the acceleration, we got to take a look at this as acceleration of A with respect to B. Okay, so this vector is in that direction. And then the component of the acceleration of this term here, and that if you do just a little sketch here, and if we look at A, acceleration of A is kind of like this, and draw some of the angles, you'll see that the angle is alpha plus beta, so we can use cosine of alpha plus beta as the component, is this component, a component of this vector, well, we have the minus sign as the component of this vector in this, along this axis here. So this then gives us another equation where we can solve the acceleration of A, B with respect to A. And so now that we know this, we can plug that into here, and then we know everything else in here. And I'm plugging in all our values, we get that is 7.47 meters per second squared. So again, I drew this in there. This is it going in this way, and this one's going in this way. And then obviously once we know these two, and we know the directions, we could figure out what the absolute acceleration of this block was if we wanted to. I think that's pretty much basically just getting the geometry correct in this case, and figuring out what the angles are between all these different axes and